Today, we will be solving quadratic equations by taking the square root. This is TEKS Algebra 2.4F. In order to take the square root, we must get whatever is squared by itself. So our first step here is to move the 4 to the other side. So I want to add 4 to both sides. Negative 4 plus 4 becomes 0. I'm left with x plus 1 squared equals 36. So now I can do the inverse operation of squaring something. The opposite of squaring something is going to be taking the square root. So I'm going to take the square root of both sides. The square root and the square, they cancel each other out. I'm left with x plus 1 equals the square root of 36. Well, what is the square root of 36? It is a perfect square, and it is a positive 6 and a negative 6. So I'm going to break this up into two solutions. X plus 1 equals a positive 6, and x plus 1 equals a negative 6. Inverse of adding 1 is going to be subtracting 1 from both sides. We have x equals 5, and we have x equals negative 7. So my two answers are 5 and negative 7. We should plug our answers in to make sure they are correct, and both of these answers will make this equation true. Okay? Same process again. We first have to get this, by itself. So we need to move this 5 to the other side. So we are going to subtract 5 from both sides. So we have x minus 2 squared equals 20. Inverse of squaring something is going to be taking the square root of both sides. Remember, whatever you do to one side, you do to the other side. So now I have x minus 2 equals the square root of 20. Well, I can't take the square root of 20, so what can I do to find the square root of 20? So you can either do the factor tree or find perfect squares that go into it. Are there any perfect squares that go into 20? 4 goes into 20, so 4 times 5 make 20. But I can take the square root of 4. So I can, when I take the square root of 4, I'm going to write it in the front. And again, taking the square root is going to leave me with a positive or a negative. So I'm going to take the square root of 4, and I'm going to write it in front of the radical. So then I have x minus 2 equals a positive and a negative 2, and the 5 stays underneath the radical. So because I'm not going to actually take the square root of 5, I'm going to leave this as one equation instead of breaking it up into two, but I still have one more step to add 2 on both sides, and I'm going to write it in front of the plus and minus. So we have x equals 2 plus and minus 2 square roots of 5. So it is two solutions, but we're going to write that as a plus and a minus. Okay? Let's try another one. So our goal again is to get this squared by itself. So first I'm going to move the 2 to the other side by adding 2 to both sides. Okay, then I want to move this 3 over. Right now this is 3 times x plus 6 squared. So in order to move the 3, the inverse of multiplying is to divide by 3, and I need to do it to both sides. So then I have x plus 6 squared equals 32. The next step to get rid of that square is to square root both sides. Okay. I can't take the square root of 32. It is not a perfect square. But what can I break up 32 into that I can take the square root of? So I think about my perfect squares, and I can break up 32 into 16 times 2. And I chose 16 and 2 because 16 is a perfect square, and I can take the square root of it. The square root of 16 is a positive or negative 4. So then I have x plus 6 equals a positive and a negative 4 square roots of 2. The next step is to subtract 6 from both sides, and I'm going to write that before the plus and minus. X equals negative 6 plus and a minus 4 square roots of 2. Now the last question for the day. Now notice that our x squared, it doesn't have anything in parentheses, but I still need to get this x squared by itself. So my first step is going to be to move the 7 to the other side. Remember, we always add and subtract first. So then I have equals to 25. Well, I need to move the 1/3 to the other side because that 1/3 is not being squared. So I can multiply both sides by 3/1. And 1/3 times 3/1 becomes 1x squared. And 25 times 3 becomes 75. The next step is to take the square root of both sides to get the x by itself. Now I can't take the square root of 25, but what can I break up 75 into? I look for perfect squares, and that's 25 times 3. And I chose 25 because it's a perfect square, and I can take the square root of it. So x equals a positive and a negative 5 square roots of 3. Hopefully this video helped you understand how to solve quadratics by taking the square root.